Hello, my name is Jonathan Tipo, and today we're going to be going over Module 8 and specifically calorimetry. So what is calorimetry? Calorimetry is really just a transfer of heat. And when we're talking about heat, we're really talking about energy. In which form? Thermal. Right? And thermal energy has to do with the movement of molecules. Now, when we talk about heat, person to person as a casual manner, we're really talking about hot or cold. But this really does not make any sense in terms of chemistry, right? Because there is just an abundance or a lack of energy. So let's take this heated container full of water. Let's say this is water, right? And we heat it over a fire. What's going to happen to the molecules? Well, they're going to start going everywhere. They're going to start bumping the walls in a way that is more harder and faster. Right? And our bodies interpret this bumping and constant bumping as hot. Versus this colder molecules, they're going to be moving slower, right? They are still going to bump into the walls, but not as hard, not as fast, not as constant. And our bodies interpret this as cold, right? And so hot and cold really does not exist in terms of scientific manners. It's really just the lack of energy or the abundance of energy. So before I actually start getting into formulas, I want to talk about something, right? And this is specific heat capacity and heat capacity, S and C respectively, right? So S is specific heat capacity, and this one's just regular heat capacity. So what is the difference between them? So specific heat capacity is in terms of joules over grams times Celsius, and heat capacity is just joules over Celsius, right? And the difference between them is that specific heat capacity is how much energy it takes to raise 1 gram of a substance by 1 Celsius, right? By 1 Celsius. So how much energy it takes to raise 1 gram of a substance by 1 Celsius versus just regular heat capacity is just energy it takes to heat all of the mass, right? To heat all of the mass by 1 Celsius. And if you'll notice right here, we have grams, and here the mass is already incorporated within this units, right? So say we have 50 grams of a substance. The specific heat capacity is involved directly within the substance, and the heat capacity varies depending on how much substance you have, right? So just remember, specific heat capacity is related to 1 gram of the substance, and heat capacity, just regular heat capacity, is related to the entire mass of the substance. And we'll see it within these two formulas, right? So for example, let's start off with this top one. This top one is where the three or the following two formulas are derived from, right? And there's really three formulas that you have to remember, and we'll go over through them. So Q, that's just heat, right? So we use Q for heat, and we know that's energy. So our units are going to be joules. Mass is M, and we know that's grams. S is actually our specific heat, and we see our units are that. And then delta T is temperature in terms of Celsius, right? And why do we use Celsius instead of Kelvin? Well, remember that this is delta, so we are looking at the final temperature minus initial, and we're really looking in the change in temperature, right? And remember that a change in 1 degree Kelvin is equal to 1 degree Celsius, right? So the actual change, if I change by 20 degrees, it's still going to be the same whether or not you're changing by Kelvin or Celsius, because the steps and the intervals between each Kelvin 1 and Kelvin 2 is equal to the interval between Celsius 1 and Celsius 2, right? So it doesn't really matter whether or not we're using Kelvin or Celsius, so that's why we just leave it as Celsius. And let's look down here at the Q equals cat equation, the Q cat equation. And we are looking at Q, again, is heat, and heat is energy, and energy is in joules. C is just heat capacity, and remember that heat capacity is just J over C, or joules over Celsius. And then again, we are looking at the change in temperature. And that's also in C. So if you notice, because on the top, right, because we have the specific heat capacity, we have to multiply it by the mass, right? Because we know how much each gram of the substance changes, but we don't know how much grams we have. And that's why this is incorporated within this. And if you can see, and you'll expand this, let's just expand this real quick. So that's Q equals MSAT. And then let's expand that, right? So that's grams times grams over Celsius times just regular Celsius. You'll see that the Celsius and the grams cancel out, leaving us only with joules, right? And Q is in terms of joules. Versus if we do the QCAT equation, then we see that is joules is equal to joules over Celsius times Celsius, right? And they just cancel out, leaving joules and joules. So just remember that this heat capacity is for the entire mass, right? And so mass is already within this, and specific heat capacity is only for 1 gram of the substance. So moving on, this is the last equation that we need to know, and the last formula we need to know. And this is really just conservation of energy. So it's the same thing as conservation of mass, where we cannot create or destroy energy or mass. It can only be transferred, right? And so where do we get this energy? Well, if there's a change within a system, right? We're changing within a system, that means it has to come from the surroundings, right? So if I'm heating up a spoon, right? Heating up a spoon, and in the spoon we have a ice cube, right? Well, let's make this blue, right? And our ice cube is blue. If we're heating up an ice cube, then our system is the ice cube, and our surroundings is, well, the fire, part of the fire, right? And so all of this really just shows that energy is not created or destroyed, it's only transferred, right? So we're taking the energy from the fire and putting it into the ice cube. Okay, so the way we would do this is just use Q and Q, and remember we have 2 formulas that we can use Q from. So if this is Q system is equal to negative Q surroundings, then our Q, we can use the MSAT equation, and then say we want to use the MCAT, or yeah, the MSAT equation, or you can use the, Q equals CAT equation, or the QCAT equation, right? And then you can mix this up. You can have CAT equation versus the MSAT equation, right? And I'm saying MSAT, MCAT because it's easier for me to remember. If you have another way to remember it, then that's on you, right? Doesn't matter, as long as you remember it. There's one thing that you need to know, and it is just the specific heat of water. Specific heat of water. And you will definitely need to remember this, and that is 4.184. So that is equal to S, and remember, it's joules over grams Celsius. So that's 4.184 joules grams Celsius. And you definitely need to remember this. Okay?